In this video, I'm going to talk about exponential and logarithmic equations. So first of all, before I proceed, let me start with a question. What is the relationship between the exponential functions and the logarithmic functions? So here I have a function f of x equals e to the power of x minus 3 plus 1. Now, I'm going to find the inverse function of this function f of x. So first, I'm going to let the variable y equals e power x minus 3 plus 1. So to find the inverse function, I'm going to rearrange this equation such that x as the subject. So to do this, I shift the 1 to the other side. And to find the value of x, so I'm going to use the logarithm with base e. So, logarithm of e power x minus 3 with base e, then I'll get x minus 3. Logarithm with base e is equal to ln y minus 1. So, when I shift the 3 to the right hand side, now I get x as the subject, where x is ln y minus 1 plus 3. So this is the inverse function of the function of f of x. So when I write this inverse function in the function notation, so the inverse function of f of x is equal to ln x minus 1 plus 3. So next I have another function, h of x, where h of x is ln x minus 1 plus 3. So similarly, I'm going to find the inverse of this function h of x. And to find the inverse, I'm going to rearrange this equation such that x is the subject. So when I shift 3 to the other side, now to find the x as subject, since ln is logarithm with base of e. So now I'm going to shift the e, the base of e to the right hand side becomes exponential e to the power of y minus 3. Now I have got the x as the subject equals e power y minus 3 plus 1. So this is the inverse of the function h of x. When I write the inverse in the function notation, that is inverse of h of x is e to the power of x minus 3 plus 1. So when we compare these two inverse with the function f of x and h of x, so notice that actually the exponential function is the inverse of the logarithmic function, and at the same time, the logarithmic function is the inverse of the exponential functions. Now I'm going to double check the relationship between the exponential function and the logarithmic function by using graphical method. First, I start from the exponential function. And we know that if we carry out the reflection by using y equals x as the axis of reflection, then the image of the reflection is the inverse of the function. So from this diagram, this is the graph of the exponential function after reflection. So we find that this is the inverse of the exponential function. So next, we go to the graph of the logarithmic function. Similarly, when we carry out the reflection by using the straight line y equals x, we find that this is the inverse function of the logarithmic function. So when we compare these two diagrams, so we can see that this inverse function of the exponential function actually is same as the logarithmic function, and the inverse of the logarithmic function actually is same as the exponential function. So from this diagram, we can make conclusion that the exponential function is the inverse of the logarithmic function, and at the same time, the logarithmic function is the inverse of the exponential function. Now, when doing calculation involving exponents and logarithms, we should know some of the laws of exponents and laws of logarithm. So these are the laws of exponents we are going to use when we are doing the calculation involving the exponents, and these are some of the laws of logarithms when we are doing the calculation. So based on these laws of exponents and laws of logarithms, now we are going to try some questions. Now let's try to solve this exponential equation. When solving exponential equation, one thing important is we must make sure that the base is the same. So notice that most of the term here, the base is 3. But this term, the base is 9. But don't worry, because we can simply change 9 becomes 3 power 2. So when we expand this part, then we will get the exponential equation here. Next, I'm going to separate the index here. So when I separate the index here, I get 3 power 2. Here, I get 3 power 3. And 3 power 2 is 9. 3 power 3 is 27. And since most of the term here, the exponent is 3 power x here. So now I'm going to take out the 2 here, such that here I can see the exponent here, that is 3 power x. So from here, actually this one is the quadratic equation. But if you don't see, I just replace this 3 power x with y. So when I replace 3 power x with y and I simplify this part, now it is very clear that this equation actually is a quadratic equation. So to solve this quadratic equation, now I'm going to use the normal method. That is, I'm going to factorize this quadratic. After factorize, I find that y is 1 over 9 and y is 3. But this is not your final answer, because your final answer should be term x. So now I'm going to replace y with 3 power x. Each of the y replace back with 3 power x. Now after replace y with 3 power x, so it is very easy that you can find the value of x. So now the value of x is negative 2 and 1. Now let's try to solve this logarithmic equation. So when solving logarithmic equation, same as exponential equation, the important thing is we must make sure that the base is the same. But notice that this term, the base is 4. This term, the base is x. That is the different base. So now I'm going to change this term such that the base is 4, same as this one. So to change the base of the logarithmic term, I can use this formula. That is, logarithm of b with base a can be changed to 1 over logarithm a with base b. So now I change this logarithm 4 with base x becomes 1 over logarithm x with base 4. So now after that, in order to make the calculation becomes easier, Now I try to replace this logarithm x with base 4 with y. So when I replace this log with y, so this equation becomes simpler compared with this equation under logarithm. So now here, since there is a fraction here, now I'm going to cancel off the denominator y here. So now I multiply each term here with y. So when I multiply each term with y, now I get this one. So when I rearrange the equation, that is a quadratic equation. So now I factorize the quadratic, and I find that the value of y is 1/2 and y is 3. But this is not the final answer because the answer should be under term x. So now I'm going to replace each value of y into logarithm of x with base 4. So for the first answer, y equals 1/2. When y replaced back with logarithm x with base 4, now to find the value of x, this base when shifted to the right hand side becomes 4 power 1/2, then x is 2. For the other value, y is equal to 3. When I replace y with log x with base 4, same thing. If I want to find x, I shift the 4 to the right hand side, becomes 4 power 3. Now x is equal to 64. So finally, the value of x for this equation is 2 and 64. Now we are going to solve the simultaneous equations in exponential form. So when solving simultaneous equations, normally we are going to cancel off one of the term, either x term or y term. If we choose to cancel off x term, then we are going to set x term as the subject. If we choose to cancel off the y term, then we are going to set the term y as the subject. So now I decide to cancel off the x term. So now for the first equation, I rearrange the equation so that the x term is the subject. So 2 power x is equal to 17 minus 3 power y. This is the first equation. Now for the second equation, since I'm going to substitute 2 power x, now here I separate the index here such that it becomes 2 power x, and this one is 2 power 2, this one is 3 power x, so this one is 3 power 1, so 2 power 2 is 4, 3 power 1 is 3. So now we can substitute the 2 power x from the first equation here. So when I replace 2 power x with 17 minus 3 power y, and when I expand here, 4 times 17 is 68. But this one, 4, is not allowed to multiply with 3 because 3 is the base of the index. So we can simply write negative 4 times 3 power y, and this one is negative 3 times 3 power y. So now it seems that here this is the same term, that is 3 power y, this is 3 power y. So now we can combine these two terms, negative 4, negative 3 becomes negative 7. Now we are going to find the value of y. So now the term y, we will keep it one side. The rest of the number, we shift to the other side. So 68 and 65, we group at the other side. Then 7 shifted to the other side becomes 63 divided by 7, that is 9. Now from here, we can find the value of y is 2. So the first value of y, we have got it. Now to find the value of x, we are going to substitute this value of y into the first equation just now. So when we substitute y with 2, and when we simplify, that is 8. So now from here, we can very easily find that x is equal to 3. So therefore, x is 3 and y is 2. Now again, we are going to try this simultaneous equation, but this simultaneous equation is under logarithm form. So when solving simultaneous equation under logarithm form, the easier method is we try to change the logarithm equation into index form, and we do the calculation in the index form. That is easier. So first, I start from the second equation because I find that the second equation I can easily change the logarithm becomes index form. That is, I shift the base 2 to the right hand side, becomes 2 to the power of 5, that is 32. And solving simultaneous equation, we must decide which term should be cancelled off first, either x term or y term. So now I decide to cancel off x term, so I set x as the subject in terms of 32 plus 2y. So this is the first equation. So now for the second equation, when I try to change to index form, I found that the base is different. So when calculation involving the logarithm, make sure the base is the same. So now I'm going to change the base 4 into base 2. So now based on the law of logarithm here, now we are going to use this formula to change the base. So when I try to change to base 2, so that one is the logarithm of y with base 2 divided by logarithm of 4 with base 2. So logarithm of 4 with base 2 is equal to 2. And in order to cancel off the fraction here, now I multiply the whole equation with 2. Now I get 2 log x with base 2. Then now the 2 here will be cancelled off. This one 4 times 2 is 8. So now to change to index form, I'm going to combine these two logarithms. So when we try to combine the logarithm, we look at the law of logarithm. To combine two logarithms becomes one term, we must make sure that the coefficient here is equal to 1. And when we combine, minus becomes divide and plus becomes multiplication. So now when we look at this equation, the coefficient here is not equal to 1. So we shift the 2 on top here such that the coefficient is 1. Now these two logarithms, the coefficient is 1. Now we can combine. Since this one is negative, so negative when we combine the logarithm becomes divide. X power 2 divided by y. Now we can simply shift the base 2 to the right hand side to get the index form. So 2 to the power of 8 is equal to 256 and y shifted to the right hand side. So now the equation is already in index form. So now I can replace the x from the first equation just now. And now when I expand, I find that this is a quadratic equation. Before I further simplify, I find that if the coefficient can be further simplified, try to further simplify the coefficient here. So when I simplify, we get the quadratic equation. Then when I factorize, I get this one. Now finally, I get the value of y is 16. when I get value of y is 16, now I'm going to substitute the value of y into the first equation in order to get the value of x. So when I substitute y here, now finally I get the x is 64. So therefore x is 64 and y is 16. Now let's try this simultaneous equation. This simultaneous equation, one is index form, the other one is logarithm form. So first I'm going to change the logarithm equation into index form. So when I shift the base to the right hand side, now I get y equals x to the power of 1 over 2. So I leave this equation here. Now I go to the other equation. So before I can substitute the y into the second equation, I think that I better settle the base, because I found that the base is different. One is 2, one is 8. But now 8 I'm going to change to 2 power 3. So when changed to 2 power 3, now the base is the same, that is 2. So when the base is the same, so now means x is equal to 3y. Now then only I substitute y with x power 1 over 2 from the first equation just now. And to solve this equation, I think I'm going to square the both sides so that x power 2 is equal to 9x. So now to solve this equation, first I shift all the terms to the left hand side and I do the factorization, and I found that x is equal to 9 and also x is equal to 0. But when x is equal to 0, the logarithm with base 0 is undefined, so x equals 0 is rejected. So we only accept x is equal to 9. So when I substitute x equals 9 into the first equation, so I found that y is equal to 3. So therefore the value of x is 9 and the value of y is 3. I think that's all for now. For this topic, if you want to master it, I think you really need a lot of practice on it. You must know how to change the base from index to logarithm, from logarithm to base by using all the laws of exponential, by law of logarithm. So I really hope that this video can give you a little bit guide about how to solve the logarithm equation or the exponential equation. So thanks for watching.